Hello students. In previous video, I informed you about reaction of alcohol with PCl3 with mechanism. Now here we will check how alcohol react with PCl5 and what is its mechanism. Let's understand mechanism of that. PCl5, first of all, this one, PCl5. Two molecules of PCl5, actually what they are going to create, check. As we know, P outermost electronic configuration is 3s2 3p3. With the help of these and 3d is vacant over here. In PCl5, what P is doing, it is exciting its one-off electron from 3s to 3d, due to which 5 unpaired electrons are generated over there, and with the help of these 5 unpaired electron, it is making 5 covalent bonds with Cl. And these orbitals are vacant over there. So that vacant orbital I am drawing over here, like one I need, so one I am drawing. This is vacant 3d orbital. Now out of two, one PCl5 chlorine bond and phosphorus bond will break. How? Obviously chlorine electronegativity is more than P, so bond will break like this. And this PCl5 molecule will turns to PCl4, because now this P have lost one of its electron, so vacant orbital will generate and plus one charge will develop out it. Now the Cl negative which was generated from here, it is going to make a coordinate bond with second PCl5 molecule, due to which this PCl5 will become PCl6. And what will be the charge? Negative charge will come on this P, because Cl is going to deliver one of its extra electron. This is the extra electron from P side. This extra electron it will deliver to this P, and initially it was neutral. After getting one more extra electron, its charge will become -1. So two PCl5 molecules are turning into cations and anions. PCl4 positive and PCl6 negative. One is losing chloride and one is gaining that chloride through vacant orbital. Which vacant orbital it is using? 3d. This one. Now next what will happen? Let's check. For reaction with alcohol, out of PCl4 positive and PCl6 negative, PCl4 positive will be utilized. Reason is very obvious, because it is carrying complete positive charge, and in alcohol who is present? Oxygen is present with negative charge. Negative particle wants what? Positive particle for attack. This P also contain a vacant orbital. The vacant orbital was generated due to loss of chloride ion. So P have a vacant orbital. Oxygen with negative charge, lone pairs, vacant orbital. So everything is perfect for attack. Oxygen is going to attack on this P. Now, what will happen? This P is going to make a coordinate bond with oxygen, and oxygen is going to use its lone pair. So the positive charge of P will finish out, because oxygen is giving one of its electron to this P for bond formation. So P becomes 0, but oxygen is losing, giving its electron to P. So oxygen will have +1 charge on it. Now in this condition, you can watch the oxygen is highly unstable. Now Here we will have a role of PCl6 negative. PCl6 negative is also an unstable particle because it is a charged particle. Negative charge is over there on P. So what will happen? Chloride bond which was extra over there, it will break and Cl negative will release out from here, and that Cl negative, now it will attack on this hydrogen side, bond will break and you will have Cl, this oxygen will become stable like this, and what will generate out here? HCl. And this molecule which was PCl6 negative will become PCl5 neutral particle. Now in previous video I also told you that HCl is a strong acid. It will not remain in this condition. H positive and Cl negative again will generate out. Oxygen is more electronegative than R, means carbon. So this R have a positive charge on it. Cl negative is there. So in like PCl3, the Cl negative attacked on R, same will happen over here. Cl negative will attack from the back side, which we call SN2 mechanism on R group, and the bond between R and O will break and both electrons will shift toward oxygen, and this molecule will become oxygen with 3 lone pairs over there negative, and RCl will release out, which we want, our main product, chloroalkanes. Now what about O negative? H positive is there. In previous video also in PCl3, with PCl3 we have done same mechanism. So same will happen. H positive will attack on this oxygen and we will have Cl OH. This one molecule of RCl will be ready over there. Now what will happen next? As we know, phosphorus and chlorine, out of them electronegativity of chlorine is more. So chlorine have partial negative charge, and out of oxygen and hydrogen, hydrogen have partial positive charge due to higher electronegativity of oxygen. Now because the particles are very close to each other, so positive negative interaction will happen over there, and they will start making bond with each other. So between P and Cl, bond will break, and obviously when bond will break, electrons will shift toward chlorine, and between oxygen and hydrogen, bond will break, electrons will shift toward oxygen. Now after this breakage, the molecules will turns to in this condition. HCl will release out. Means two products are generated over there. HCl and RCl, and here we have Cl vacant. Now how this vacant orbital, here we have a vacant orbital with a +1 charge, oxygen is carrying 3 lone pairs with a negative charge. How P and O can stabilize each other? Obviously, if oxygen provides its lone pair in this vacant orbital like this, and second bond it generate like this, they all will become stable. Oxygen will left with 2 pair without any charge. P will have 5 bonds and that positive charge will also finish out. This is the third product, POCl3. POCl3, HCl and RCl. These are the main products we have during this reaction. So if I write this whole reaction, the reaction was 1 molecule of alcohol plus 1 molecule of PCl5 reacts to create 1 molecule of RCl, 1 molecule of POCl3 and 1 molecule of HCl. And this was the mechanism how alcohol reacts with PCl5 to create our main product RCl. This is the end of the video. In next video, we will check mechanism of reaction between alcohol and SOCl2 to create RCl. Thank you very much.